All right, let's start a new section. In this section, we're going to be talking almost exclusively about quadratic equations. In this part, we'll solve them. In other ones, we'll look more at the graphs. And in other sections, we'll be looking at different formulas or different forms of the equation of a quadratic function and the information that those give to us. Today, though, we'll be focusing on solving quadratic equations. We'll first use the square root principle to find x-intercepts, then we'll try completing the square and then using the square root principle. And then we might have a chance to look at an applied problem, but we'll have lots of those as we go. So first off, we've already looked at quadratic functions a little bit and quadratic equations in that we've done a whole lot of factoring. Remember all of those equations that had an x squared, x, and a number, and we've gotten really good at factoring those or using the quadratic formula to solve those. Hopefully we've used the quadratic formula. If not, we'll be using that right away. So we've had a little bit of practice factoring these. So what we want to focus on today is solving a quadratic equation. And what we do to solve a quadratic equation is, in a function, we'll let the f of x equals 0 or y equals 0. That's where we'd want to find the x-intercepts, or is y is equal to 0, and then solve that equation. I like this point that I make down here at the bottom, that the x value of the x-intercept of a quadratic function and the solutions to a quadratic equation are the same number. So when we solve a quadratic equation, we're actually also determining the x-intercepts of that of the function. So let's try a couple. Here's just a quick example. F of x equals x squared minus 25. I've taken the liberty of graphing that down below. You can't really see it that well, but this number is a minus 5 and this is a positive 5. So I just used a grapher to graph that. So what I'm wanting to do is I want to be able to take any quadratic equation like that and figure out where the x-intercepts are. So to do that, as I said on the last page, I let f of x equals 0, like I've done here, and then I solve this equation. Since it's a quadratic equation, I can factor, and I recognize this part here as being a difference of squares. And so I will factor this. It'll be x minus 5, x plus 5. Now I'll use the principle of zeros to solve. So if I have two things that multiply together to give me 0, one of them has to be 0. So x minus 5 is equal to 0, or x plus 5 has to be equal to 0. And of course on this side I'll get x equals 5, and on this side I'll get x is equal to minus 5. So the solutions to this quadratic equation are 5 and minus 5. Now, looking at the function, these numbers here also give me the values of x where that thing or where the graph crosses this x-axis. So this point here, the x value would be 5, and over here the x value would be minus 5. Of course, when it's crossing the axis, the y value would be 0. So these are the x-intercepts for this function. These over here are the solutions to this quadratic equation. Let's try another one. Question says 5x squared is equal to 8x minus 3. What I'm wanting to do is solve this equation. And then if they say find the x-intercepts, really I should have written this in functional notation. But we'll get to that in a second. Let's take the equation, 5x squared, and let's bring everything over to the left side. Minus 8x plus 3 is equal to 0. So this is a quadratic equation. The function that would be associated with that would be f of x is equal to 5x squared minus, squared minus 8x plus 3. That'd be the function. So for this one, I'd be looking for x-intercepts. For this one, I'm just looking for solutions. Okay, so now what I want to do is I want to solve this. It's a quadratic, so to solve it, typically I'm going to factor that, or I might have to throw it into a formula in order to determine the x-intercepts or the solutions. Let's try factoring though. 5 times 3 is 15, and 3 plus 5, yeah, that'd work. Let's factor it. So I'm just going to do a guess and check. Equals 0. I'm putting a 5x here and an x there. And I'm going to put, I don't know, a 3 or a 1. Maybe I'll put a 1 here and a 3 there. And let's make them both minus. Let's see, 5x squared minus 5 minus 3. Yeah, that gives me minus 8. Minus 3 times minus 1 gives me plus 3. Yeah, that works. But you can factor that however you'd like. Okay, now I'm at property of 0, 0 property. Two things multiplied together give me 0. One's got to be 0. So 5x minus 3 equals 0, or x minus 1 is equal to 0. Solving this, I'd get x is equal to a positive 3/5. For this one, I'd get x is equal to a positive 1. So the solutions to that equation up here are 3/5 and 1. The x-intercepts, if this were my function, would be 3/5 and 0 and 1 and 0. Those would be the x-intercepts for that function. Okay, let's try a couple more. Okay, well that's quite a few more. Um, rather than try another question, maybe I should have indicated here, try some. Try some on your own from the textbook. Maybe pause, try some, just get that feel for what solutions are and for what x-intercepts are. Okay, when you're ready, hit play. So another way that we can solve quadratic equations is using something called the principle of square roots. And the principle of square roots, similar to the principle of powers that we saw in the last section in radicals, says that if I take an equation like x squared is equal to 36, if I square root this side, I can do that as long as I square root this side. So if I square root both sides, the equality remains. By square rooting this side, I come up with just simply x. With square rooting this side, I come up with, in this case, I come up with 6. Now I have one little issue with this, because when I look back here, in quadratic functions, there's always seemed to be two answers to them. Sometimes it's the same answer, but more often than not, it's two answers. When I look at here, I see that yes, 6 squared is equal to 36, but also, if I were to put a negative 6 in there and square it, that would also give me a positive 36. So whenever I use the principle of square roots, I need to remember that I put a plus and a minus on this right-hand side. Okay, so my answers for this question will actually be plus or minus 6. Here's another example where I could use the um, principle of square roots. I'm going to square root this. Well, let me write it over again. X minus 7 squared equals 9. So I will square root this side, and I'll square root this side, making sure I put a plus or minus in there. A lot of people forget that plus or minus. Don't you forget it. Okay, so when I square root, the square and the square root cancel out, so I'm just left with x minus 7 on the left side, and then on the right side I have plus or minus square root of 9 is 3. Now notice that I'm not done my question yet here, and I've come up with something a little bit awkward, that I have two numbers here. So what I like to do is I like to rewrite this in two steps. So I'll say x minus 7 is equal to a positive 3, or x minus 7 is equal to a negative 3. Now I've got two equations that I can solve. And notice I'm going to come up with two answers. Add 7 to each side. Over here, add 7 to each side. So my solutions to this equation are both 10 and 4. Might as well check. 10 minus 7 is 3. 3 squared, 9. Yep. Let's check 4. 4 minus 7, negative 3. Negative 3 all squared, positive 9. They both check. How about this other one up here? Looks like it's not in the right form yet, so let me push the 8 over to the other side. It'll become negative. I'll divide both sides by minus 5, so I'm going to get 8/5. So x squared is equal to 8/5. Now I'll use the principle of square roots, so I'll square root both sides. Let me use green for that. Square root, remembering my plus or minus here. So on this side I come up with x, on this side I come up with a plus or minus square root of 8/5. And at this point I'm feeling pretty good. However, do you notice something here that I need to fix? Hopefully you've noticed that on the bottom here I have this square root. That's a thou shalt not. Remember that? So I'm going to rewrite this as the square root of 8 over the square root of 5. And then to rationalize that, I'm going to multiply both the top and the bottom by the square root of 5. Okay, so I'll come up with x is equal to plus or minus 8 times 5 is 40. Oh, the square root of 40. I'm running out of room. Over root of 5 times root of 5 is root of 25, which is 5. Notice I cannot divide 5 into 40 because this one's in the square root and this one isn't, so I can't do that. But it looks like there's some more simplifying that I can do. Because 40 is the same thing as the square root of 4 times the square root of 10, all over 5. And so the square root of 4 is 2. So this would be plus or minus 2 root 10 all over 5. Again, I can't simplify that because one's outside, one's inside of a radical. Can't simplify those. This would be my final answer. Okay, another way that we can solve quadratic equations, and this works out okay, but there's lots of ways that you can solve quadratic equations, and so this is one tool that you can use, and you may or may not use it a ton. For example, in this case, there's no way I'd use completing the square. I'd probably just factor it. But I wanted to show you this way because it is handy to use sometimes. So it's a nice tool to have in your belt if you want to talk about it that way. Okay, so in this case here, they ask us to solve this by completing the square. Completing the square, what I'm doing is I'm trying to make something that looks like this. And then I use the principle of square roots on it. So I'm trying to get this x squared plus 6x plus 8 to look like that. Okay, let me show you just the process that you go through for that. What you do first is you isolate the two x terms. So I'm going to push that 8 over to the other side. That's my first step. So isolate the x's. And then I, as they say here, complete the square. Complete the square, what you do every time is you take the coefficient of x and you divide it by 2. So I'm going to take 6 and divide it by 2, always divide it by 2, and then I'm going to square that result. So 6 divided by 2 is 3, 3 squared is 9. And I'm going to write that number right here. Okay, let me write everything else out. Now, one of the problems that I have there, well, let me fix that. I'm going to use a different color just so you can keep track of what things new. So here I threw a 9 in out of the blue, and I can't do that and maintain the equality of this equation. So if I add 9 to this side, I'm going to have to add 9 to the other side. I guess I could also have subtracted 9 on this side, but in this particular case it works to our advantage to put the 9 on the other side. So now my next step is to factor what's on the left side here. And you'll notice that when you factor it, two things that multiply to 9 and add to 6 are 3 and 3. Minus 8 plus 9 is 1. So on the left side I get x plus 3 squared is equal to 1. Okay, now see, that's what we had back here, something like that. Something squared is equal to a number. And so now what I'd like to do is solve this. So I'm going to use the principle of square roots. I'll square root both sides. X plus 3 is equal to the plus or minus square root of 1. Notice that I guess I skipped a step there, but if you do them enough times, you can just go from this step to this step. But if you want, it's never a bad idea to write in all of the steps that you're doing. Okay, so now I have to solve. But I have two numbers over here, so I need to write these out as two separate things. So x plus 3 is equal to a positive 1. Notice the square root of 1 is just 1. Or x plus 3 is equal to a negative 1. So in this case here, when I take the 3 over to the other side, I get a negative 2. In this case here, when I take the 3 over to the other side, I get a negative 4. So those are my two solutions to the original equation. Now they also wanted me to solve that equation by factoring. Let's just factor it too. 6x plus 8 is equal to 0. So if I were to factor this, I'm looking for two numbers that multiply to 8 and add to 6. And of course those numbers are x plus 4 and x plus 2. Using the 0 property, x plus 4 must be equal to 0, or x plus 2 is equal to 0. Therefore, x is equal to minus 4, or x is equal to a minus 2. So there's my two solutions if I factor it. Notice here, I get the exact same solutions. Which way did you like better? Myself, just in terms of the amount of work, it looked like factoring was quite a bit easier. And that's a nice thing when you're looking at quadratic equations, that sometimes factoring is easier, but sometimes, like a question like this one, using the square root principle right off the bat is easier to solve this one than having to FOIL all this out and bringing the 9 over to the other side and then trying to factor. So there's advantages to using each one of the methods. Let's just try one more where there's a little bit of a twist in our tail here. So what I want to do is I want to complete the square. I have isolated the x's here, and so I'm going to, I'm just noticing that there's a factor of 2 there. Let me take that factor of 2 out, and so I'll have x squared plus 3x is equal to 5. Now what I want to do is I want to complete the square inside here. Actually, I want to get rid of this 2 as well. Let's divide both sides by 2. So I have x squared plus 3x is equal to, this will be 5 over 2. Okay, so now I want to complete the square on this side. So x squared plus 3x plus, now to get this next number, I know I have to take 3 and divide it by 2 and then square it. So that'll be 9 over 4. Because 3 squared, 2 squared, 9 over 4 equals 5 over 2. Am I done? Hopefully you recognize that this is different, and so I need to also add that to the other side. Okay, so on this side, I factor, and notice what always happens with when you factor this, that this number here is always whatever you had right there. Whenever you take this number and divide it by 2, that's the number that goes here. Just before you square it, it's whatever you have before that. Is equal to, and when we add these, this would be 10 quarters plus 9 quarters would be 19 quarters. Okay, so now in solving this equation, I'll use the principle of square roots. So I'll square root both sides. X plus 3 halves squared equals 19 over 4. So I'm going to square root this side and square root this side with a plus or minus. I don't know if I've forgotten that one yet. So this would be x plus 3 halves is equal to the square root. I'm going to break these up. The plus or minus square root of 19 over the square root of 4, which is 2. Now to solve for x, I'll move this to the other side, and I'll get the plus or minus square root of 19 over 2 minus 3 over 2. And finally, since they have a common denominator, I can add the top numbers, or subtract them in this case, all over 2. Just write it with one denominator. Notice I didn't write two answers here, but I do still have two answers. I have a plus or minus the square root of 19 minus 3 over 2. So there still are two answers here. If I wanted to, typically this is where we leave it, but if you wanted to figure out an exact, not an exact, but an approximation, you could figure out what the square root of 19 would be. It'd be 4.4 something. So 4.4 minus 3 is 1.4 divided by 2 is about approximately 0.7, and then you do a minus 4.4, that'd be minus 7 divided by 2 minus 3 point something or other. But you could figure them out in decimals if you wanted to. All right, try some questions. That's a nice little introduction to solving quadratic equations. Hopefully that gives you some tools that you can be successful. If if you have any questions on any of these concepts, feel free to contact your instructor.